All right, everyone, Chapter 5 practice test. We're looking at number 9, which is another take on the classic balloon problem that you'll see in every calculus book. So let's head on over to the screen and see what we got. A balloon in the shape of a sphere is being blown up, and the volume is increasing at a rate of 4 cubic inches per second. At what rate is the radius increasing? When the radius is 1 inch. Now our balloon here, of course, is a lot bigger than 1 inch, and probably if we were going to inflate this, you're going to have to inflate it at a lot faster rate than 4 cubic inches per second, but I guess that's not so much part of the problem. But I think we hopefully understand what this looks like, and our next step after we figure that out is to create a mathematical model. Since we're dealing with the volume of the balloon, it's probably a good idea to get the volume formula for a sphere, which is 4/3 pi r cubed, and that's our mathematical model for the volume of the sphere. Our equation is already in 2 variables, so we're pretty set to go here. After we create our mathematical model, we're going to take our derivative. I've done this a few times in the last 24 hours, but I know that maybe you're not watching all these videos that I'm putting up the way I'm making them. So I'm going to remind you that we're taking the derivative with respect to t on both sides, and when we do that, we have to make sure that the variable actually matches our variable of differentiation. So they don't match. This time when I do this, I think I'm going to be kind of slow about the process. So if you take the derivative with respect to v, what I'm going to do is I'm going to take the derivative of v with respect to v, and then I'm going to multiply this by dv dt. Okay. That's the chain rule. Same thing on this side. I'm going to take the derivative with respect to r, and then I'm going to multiply by dr dt. Again, notice now the variables match, and we can take the derivative like normal. So the derivative of v with respect to v, that's just 1. The derivative of 4/3 pi r cubed, that is 4 pi r squared, and then multiplied by dr dt. With our derivative intact, we're going to substitute the current state of the balloon. So we know that the volume is increasing at 4 cubic inches per second. So that's going to be equal to 4 pi. We know that the current radius is 1 inch, giving us this really nice looking equation. Next, your step is to solve for dr dt, and that gives me a dr dt equals 1 over pi. So 1 over pi, it looks like our radius is increasing, which should make sense with what you know. If you're increasing the volume of your balloon, then your radius should also be increasing. So when the balloon's radius is 1 inch, its radius is increasing at a rate of 1 over pi, which is about 0.3183 inches per second. So that's the end of that one. Pretty easy today, and I'll see you next time for more calculus problems. Bye-bye.